All right. Welcome, everybody. Today, this is our weekly OPI Lifecycle Provisioning Technical Work Group. Let me share just a reminder for the recording and for the people who are just joining, what are we working on? And then we can start the lively discussion. All right, so this is the main page for our group, as usual. And for the past several weeks, we are working on boot sequencing. So for boot sequencing, this is our main page. Our main page has a lot of content already. And the boot sequencing page is talking about, different terminology. We created this table. Feel free to add and read what these different acronyms mean. I found it extremely helpful to just centralize all of these definitions into one place. We're talking about different entities that participate in the boot sequencing process. We're talking about different use cases, a lot of assumptions here. We created a vendor DPU survey that Intel was already responded to this. Other vendors still haven't. So if you can go ahead and push your company to respond to the survey, we'll really appreciate that. And then this page on a very high level, talking about 4 different scenarios: initial boot up, what happens when the server just powered on, then the reboot use case, the graceful shutdown of DPU in the server, and then the error handling. So for the past several weeks, we've been focusing on the first use case, which is what happens in the initial boot up. So I created a separate page here, call it coordination. So this talks about all the different initial boot up approaches. Currently, we have on our table 3 main approaches that we're discussing. And once we finish the discussion, we will vote and choose one approach, which will be official adopted OPI methodology. Just a quick high-level survey on what the approaches are. The first approach is in-band PCI Express. Can we use a PCI Express in-band methodology in order to synchronize between the host and the DPU and boot process? This is a proposal from Reza, HP, to create a new physical functions, for example. And there are several comments here, so feel free to read all the comments about different approaches. But this is our number 1 investigation. The second approach was proposed by Intel, and this is relying on the option ROM, the driver ready check approach. So once DPU IPU card being enumerated, at the end of enumeration process, after the discovery happens, there is an option ROM, and the driver is being proposed to the host operating system in order to communicate. So the idea here is to pause at this specific time and implement any kind of boot synchronization that we want in that specific moment in time. And again, there are a lot of different nuances and comments in GitHub, and probably we'll deep dive into that today. So yeah, Dan, thank you for, not sure if he's on the call, but Intel, thank you for adding all these pros and cons on the summary here. The third approach is what we see widely adopted today. Again, according to all the public information, what we see today, the adoption is around option number 3. The integration between the DPUs and the server providers, usually the most significant ones are usually using the out-of-band with platform or server BMC. This is a diagram that Lee created for us, and Lee couldn't make it today at the meeting. So anyways, he'll watch the recording. So this option is talking about we cannot solve this in-band. We need to involve out of band. So basically the synchronization happening by platform or server BMC assistance. We can discuss all the different protocols, the PLDMs over MCTP, for example, as one option. There is a PLDM RDE for Redfish, how we carry Redfish on top of PLDM. SPDM, another approach here, I2C and CSI OEM commands, and the recent addition from both Lee and Reza around USB as well. We want if we take in this approach, obviously we want to absolutely discuss USB as a future technology being standardized in PCI Express on the CAM connector and removing all these different cables and increasing the speeds for communication. So USB is definitely one of the most interesting approaches if we're talking about out of band. I hope this gives you in 5 minutes, very quick overview, what happened so far. So I'm going to open this for different comments. If people want to take a shot and start the discussion, I'm here to facilitate that. So either you don't have a lot of raised hands, but you can unmute yourselves and
yeah, thanks, Boris. This is Reza. I'd like to comment on the proposal from Intel. So first of all, I think the idea of abstracting the complexity and the uniqueness of each card away in an option ROM, I think that's highly desirable. So that way we don't have to generate any new code, and that can evolve over time. But in talking to our option ROM guys, they indicated that the option ROM runs at the end of post, and it was my understanding that at least one of the intents of the Intel proposal, and I'm sorry, Dan is probably not here to comment on this, but I wish he was that as the card is discovered, with the assumption that only physical function 0 is functional and accessible, that we would use the option ROM to stall until the rest of the OS on the card boots up and makes available the software-defined functions for the card. And that way, when that is done, when those become visible, then BIOS or UEFI can continue with its discovery of the PCIe structure, bus device function structure for that card before moving on to the next card in the system. And it doesn't necessarily have to be an XPU, right? So, and I ask about, well, can we rewrite the code so that we can to execute the option ROM upon discovery of the card instead of waiting until the end of post. Post is power on self-test for those who are not familiar. So that's pretty much the end of where UEFI runs, but just before it hands off to some OS. But basically at the time of that, discovery, the system is not really stable, and rewriting the code is going to be a major lift to do that. But I'd certainly like some more comments on the idea, because abstracting it, I think is a really good idea.
Thanks, Reza. Any comments from anybody else on the 3 approaches? I really want maybe DPU vendors to step in I see here Marvell representation quite good and Pensando representation, Vipin. So can you start, kind of hashing out what the approaches that you prefer or see?
Yeah, so Boris, let me speak. I would say that, number one seems decent to me, largely because doing number two requires a certain specific implementation of the devices so that it can present itself within the specified period. Basically, what approach two is saying is that you need to look like a regular NIC to the host. And I do understand the sentiment behind it. What Dan was mentioning is that for a cloud provider, that's a minimum. You should look like that. But that's why, assuming that cloud is not the only use case, where sometimes you may have to control these things from the server, and or rather integration with server is needed here. In that case, I would say that, you don't have hardware that could present itself as a fully functional device within PCI time limits, then option two is certainly out. So given that, I would say that, I do understand that's how world has been working, but TPUs present, different stuff. And so in that case, I'm good with one, or if approach three is good, two is something that I don't know it'll work.
Between 1 and 3, do you have any preference?
One is preferable. Yeah, I did talk to a few folks in AMD as well before speaking about it.
Sure. Thanks, Vipin.
Yeah, thanks.
This is Danilo Grana from ARM. I would like to bring one concern about option two. So for the ROM option, it means what the drivers should be stored in the ROM by the DPU vendor. So for the vertical integration, it works because you know your platform, you know your host, you know your firmware, so you can provide the correct driver in the ROM. But for example, if you have different types of the hosts, for example, you may have ARM platform, so it means what the ROM may need to have the both drivers for x86 and ARM platforms. So it means there are possible issues with the compatibility, how the DPU vendor makes sure what the drivers works on all platforms. And another thing, if the DPU is the discrete card, like a PCI card, and there is another platform, new version of the host platform is released, there is a possibility what this card will not work on that platform because it doesn't have the driver in the ROM.
So Daniel, let me ask just a clarifying question for this comment. If we put DPUs aside for a second, isn't that how the drivers being offered to the servers in a regular standard NICs today using the option ROM?
I think that was an issue for ARM, at least in the past, because most of the cards provided only x86 drivers in the ROM, and there are no ARM drivers, so those cards will not be compatible with the ARM platforms. So that's the reason why I'm bringing up that issue. So it's a question for the DPU vendors, how they're going to handle multiple different types of the hosts, because if they want to handle support multiple hosts, they need to provide multiple drivers. Yeah. It means they need to have bigger ROM. It may increase the cost of the board. As well, how they can ensure what all those drivers are compatible with the firmware on different platforms. That's another question.
I really like your comment. I'm thinking, how can we document this without losing that comment? Can you maybe either open pull request or send an email so I can open for you, whatever you feel comfortable with, Daniel. I just don't want to lose a comment about ARM versus x86 in option number 2.
So maybe if you want, Boris, I can give a few words about our experience with that.
Yeah.
Okay, so we provide platforms also for ARM-based machines. Okay, like a host, and we plugged in multiple GPUs. Okay, and Daniel, this is the same story with GPUs. Okay, so if you take NVIDIA-based GPUs or like other based, I don't want to say names, okay, but most of the PCI idling cards in the world, they do not provide ARM-based firmwares. AMD lately, for the last 1 or 2 generations, have been providing dual firmware for UEFI, one for ARM and one for x86, 64-bit, both of them. So the market is moving, to provide different firmwares for different platforms. Okay, cost-wise, everything is nothing. Okay? This is like a very minor cost thing. Okay, the firmwares, if you look at them, typical firmwares, we're talking about 4 megabit or 8 megabit SPI ROMs that are, way, those are fraction from cost point of view.
Are they provided in the same? How do I phrase this? So are both provided on the same card, or are there different part numbers for the cards?
Same card.
Same card. Okay.
Yeah, and because of it's UEFI, through UEFI and through the, you can examine the EFI binary that is inside the SPI flash, and accordingly you can load the correct one. I can tell you beyond that, we've done a project before that we have integrated QEMU inside the UEFI Tiano Core open source BIOS. Okay, and if there is no ARM version, we load the x86 version and then we QEMU that. Okay, QEMU by QEMU means that we emulate the x86 instruction set under ARM. And this is only purely just to initialize the card. Okay.
Thanks, Rabih. So what I want also to do is I want to flash you a new folder that I created with the Intel help, and then I do want to hear from Marvell as well. So let me share that. So under the provisioning lifecycle, I created a folder called vendors. And this folder is supposed to represent different vendors' view if they want to kind of express their thoughts, which is not official OPI adopted position. We do wanted to give the platform to kind of submit that. So the first submission that we have is from Intel, Intel IPU. You can go ahead and read this document. We are not probably going to spend a lot of time since Dan is not here as well on this, their view. But if you're interested in how Intel IPU work, or at least think they're going to work in the provisioning kind of method, so by all means, go into that space. And what I want to encourage is I want to encourage all the other DPU vendors, and Vipin for you, and Chetan for Marvell as well, Chetan and Desh. If you want to, please create subfolders here for Vipin Sandhu and Marvell and NVIDIA as well, if you're on the call. If you want to provide your kind of unique view of what you think we should do, and then we can review it together. This page also holds the reply on the survey that I mentioned before that Riza created, this DPU vendor survey. So the replies go into that folder as well. So you can, Riza for you, you can go ahead and read the Intel response, what they have on the survey. And Chetan, Desh from Marvell, we do expect the survey response as well. We haven't received any yet.
Yeah, I did receive some responses from Chetan.
Okay, good. So we can post the responses, Reza or Chetan, we can post them in the vendors folder if you want to. I think that will be available. And Vipin, it's an action item to you if you can help answering those questions from AMD Pensando perspective in that folder as well.
Yes, Boris, I'll take care of that. How quickly is that needed? I may take a little bit longer, but I will definitely get back.
Sure, thanks.
Thanks.
And then from Marvell perspective, Chetan, you're going to, yeah, I see you unmuted. So there is a Marvell review comments here on this pull request, or you can, speak freely, whatever you feel like. So what's Marvell point of view? Go ahead.
In general, Marvell is flexible on the approaches. We can, but we have to drill down on the specifics, and we will have comments. Unfortunately, today we don't have a response, Boris. So maybe we can add those offline.
Sure, thanks. So I do wanted to flash out this pull request from this, I think Satananda, if I remember. So
Correct.
So this has already a few comments here on the approach number 0. So Riza, it's for you. You can look it through and give your comments. I see Lee already started to put his comments here inside. So this is commenting on option number 1. There is also this config retrace status with CRS that can extension. So we can also discuss that as well as being one of the approaches. We see the pros and cons here. So I do encourage people to go and look. There are a few questions on approach number 2 as well. So that's, the only response that I have visibility to from Marvell folks as well. So yeah, action item is go and read this response and comment on the pull request. And Daniel, I'm not sure if we close that action item, but I don't want to lose your comment regarding the dual support from x86 and ARM. So either you can post a pull request or let me know. I can do it for you. In option number 2, we want to capture that comment of yours.
I can do that. I'll post the comment.
Perfect. Thank you. And I do want to say, without disclosing any other names, but so we have one DPU vendor that explicitly requested option number 3. They believe that option number 3 is the best option. Basically, the argument here is that BMC is and should be responsible for any boot sequencing issues. And even if we can solve today the invent PCI Express options, there are going to be a lot of unexpected variables going into the future. So it's never going to be a bulletproof solution if we are not going to involve BMC. So at least one DPU vendor expressed their preference in option number 3. I just wanted to flush it out so people are aware and at least have a little bit different perspective that we didn't hear so far, the preference on option number 3. So it wasn't captured anywhere, unfortunately, yet, but hopefully I'll make them to make this public info.
Yeah, as a system vendor, I mean, I proposed, option 1 and 3 there in terms of in-band and out-of-band, but our preference is certainly for option number 1. Because that is the standard flow today, involving the BMC. There's some handoff that needs to take place. That while we've done it for one-off situation, it's not necessarily scalable. So our preference would be for the in-band PCI.
Understood.
Do we expect that the BMC always will be on the host with the GPU, or there are configuration without BMC?
I'm not aware of any
Server providers without BMC. Yeah.
right. Yeah.
Answer a question, Daniel?
Yes, so we put it as the requirement to have the BMC in order to have the DPU discrete card on the platform.
I don't think we require at this moment. What the reason I'm saying we don't know of any server providers that don't put any BMC. If that changes the flow, or if there's something, a use case that you find interesting, we definitely can discuss it, right? I don't want to exclude anything, but I don't want also to spend a lot of cycles talking about unrealistic scenarios. So just let us know if you think it's a real use case when we have servers without any board management control.
Okay, I'm just trying to say for option 3, it will be hard requirement for the DPU to have the BMC.
No, we're not talking about BMC on the DPU.
I'm talking to have the BMC on the host. So for option 3, BMC required for DPU in general to work on the host, right? Is that correct assumption?
Yes, I think the broader assumption is all hosts have a BMC.
Yeah. Somebody needs to control the temperature, the fans, the power supplies. So we do, at least I am not aware of any server providers that don't have BMC. We don't require for DPU to have BMC, we call it AMC, added management controller. So we don't require DPU vendor to put additional BMC on the card, but we do expect that all servers will have BMC in the server.
Okay, thanks.
Do you know what is the status when it comes to a multi-node BMC setups? If the same thing is usable? Like a single BMC that controls multiple nodes.
Yeah, I think that's the case where there is a chassis management controller. So that's a CMC.
I think Lee answered some of that on the multi-host support.
Mhm.
Here, you can see his reply. Maybe relevant, maybe not to the discussion, but you can look it up. So yeah, multiple BMCs on the same bus or CMC, like Riza is saying, that's, I think, reasonable approaches.
Yeah, similar comment to what Boris said. Even, in a chassis, there's normally shared resources such as power supplies and fans for the multi-host case. And so there is a chassis management controller that takes care of those environmental conditions. And so that would be the same entity that would essentially manage a multi-host XPU.
So if no other comments from people, I do want to raise, even if Dan is not here on the call, but at least I want to have this discussion. Maybe people can just comment freely. So I do want to address Dan's concerns. Dan is talking quite a lot about the standard or compliant PCI Express cards versus not compliant PCI Express. So we need, at some point, we need to address it, right? So we need to discuss it. So I think that Riza and Vipin, you provided some visibility into that conversation, but I want to make it crystal clear, like the concerns from Intel that we're trying to, and I'm advocating for Dan for a second, right? So the concern from Intel is that we're trying to solve an esoteric use case that we shouldn't focus on, that today, the specific vendors are not PCI Express spec compliant. And this is why they're not up and running within specific timeout period, a specific time period, and not answering or answering incorrectly on the PCI Express. And the concern is that we as a technical group trying to solve or overcome those issues, which ideally, we need to just say that all DPUs are, first of all, PCI Express compliant. And if they are, then we need to solve the boot coordination issues, having that as an assumption, which we weren't operating so far under that assumption. So I'm not agreeing or disagreeing. I have my opinion. I just want to facilitate the discussion because we need to address Intel concerns, whether this use case is a valid one or we kind of really trying to overcome a disadvantage of specific vendor or several vendors which are not PCI Express compliant. That's why we cannot really discuss any other options, and we kind of forced into that conversation because today's generation is not PCI Express compliant. So any comments, freely just, unmute yourselves. Let's have an honest conversation.
Yeah, I think Dan raises a very important point that we need to dissect a little bit. And so while we do understand that today some cards are not PCI or PCI compliant, I think, what does PCI compliant mean in the future? In the context of software-defined personalities. Today, before DPUs and Smart I/O cards, we've been accustomed to cards having their full capability detectable in hardware 2 to 3 seconds after reset is released. All their functions are fully available. I think, one of the compliant. Now, is that possible moving forward in the software-defined world? I think we can stipulate that physical function 0 should be available right after reset and should be functional right after reset. But in this evolving world of software-defined personality, where a card doesn't know what functions it's going to have until the software, until its OS is booted, essentially. It doesn't know if it's going to be a network controller, or it's going to be a storage controller, or it's going to be a GPU. There are certain capabilities that are software defined, and so those PCI registers are not going to be defined until the software runs. And so, we're sort of splitting hairs here in terms of what does PCI compliant mean. And I would like to say that for this emerging class of cards, that function 0 must be available. And we want to give the card some time to boot up so that the other, bus device functions become available. And that's the point in which, UEFI will go and enumerate the rest of the bus device functions on that card. So, we could stipulate that all of the functions should be available. But I think that, that will limit the flexibility that these cards offer.
So let me just have a question. Okay, so sorry, I wasn't last meeting, but I've seen the YouTube video. It is a hot topic. Okay, it's a very important topic. So the thing is like this. I don't want to say I'm with or with that, but even if you have a physical function 0, okay, and in runtime you would add like additional 7 physical functions. Okay, how would there is no resource for those. If UEFI does not see those, it's not gonna allocate memory for those physical function devices, unless you start supporting PCI hot plug capability, and or over reserving, over provisioning memory for that device. So did I miss something from? I mean,
Reza, you want to quickly go through the proposal number one,
Yes.
when we expose physical function 0, and then the BIOS itself will wait in the state until the status registers indicates that the card is booted completely?
Yeah, I think that pretty much covers it. The idea, Rahim, is that the physical function 0 will have a set of PCI architected capability registers that BIOS can or UEFI can program to, that will discover this physical function 0 and know exactly where these registers are located and what the bits mean, and just poll waiting for the OS to boot. And it will then know, UEFI will then know that, okay, the OS is booted, so now all the bus device functions on this card are now visible, and now I can go ahead and enumerate those. That's the idea behind these set of registers. And of course, there are some registers in there as well to do some error handling in the event that there's a crash or some other error. But that's the intent, is to wait until all the bus device functions are available before proceeding to the next card. And so that's the time when we would allocate the resources for those bus device functions.
So it's an additional extended capability. It's additional capability list on the config space of pair on the DPU devices. This is what is.
Yes, and it's preceded by the definition of a new class of cards, and with two subclasses. So a new class of cards for XPUs, and then two subclasses, one for with an AMC and one for without an AMC.
Yeah, but what happens with silicon that does not have this capability list?
Right. So, anything in PCI we know takes, at least one generation for a silicon spin. So this is a future capability.
Yeah, what we're saying that if DPU vendors designing the next generation and we adopt that and the idea from Reza is to take this proposal, if we feel that is important, and to take it to PCI Express SIG, right? So once it's in PCI Express SIG, then we expect all the DPU vendors that are currently planning the next generation cards that will have this physical function 0 with a new class available on the next generation.
And the proposal, as it's written here, is not written in stone, right? Obviously, we need feedback in terms of more registers or even bit definitions, right? So this is intended to, spawn conversation and better ideas.
So the thing is like this, today there is already silicon available. So there are multiple approaches for building a DPU. One of them is building a custom silicon. One of them is using an off-the-shelf SoC, and the third one is using an FPGA, right? FPGA can use this today, right? Because it can, you can reprogram that FPGA to add the extended capability structure and, go with it. Current silicon, silicon that is purposely built to be DPU, right? Boris, to be honest, we're talking about 2 generations at least of PCI SIG.
Yep.
Because until you go to PCI SIG and convince them that this is worth looking at, and the list over there is huge. Okay, it's not only the DPU guys that want this capability structure. They have probably a list of 20, 30 different capability structures that they're looking for. So my gut feeling is that for future designs, this is a long shot. Okay, this is at least 2 generations or 3 generations of DPUs before
I'm not disagreeing, but we need to start somewhere in order for this to happen in 2 generations.
And certainly,
if you're saying that we need one second, Reza. If you're saying that we need a more timely and quick solution for the existing cards, I also don't disagree with you, right? So
Mhm.
maybe those are the same, maybe those are different solutions. So
I'm
absolutely.
always with the things that reuse the current solutions, okay, and go to the market for real use cases. Okay, this is I know this is very important, right? This is extremely important. But if we suggest things that's going to be happening in 2 generations, okay, I think that we're losing the point. This is my honest opinion. But beyond that, okay, there are companies that are using also off-the-shelf SoCs. Okay, that they're not using custom-built DPUs, SoCs for DPUs, or FPGAs. Okay, and those off-the-shelf SoCs will never have anything that is custom. Okay, I mean, you cannot really configure them to add things like that. Okay, and I'm not talking about us. Okay, I'm talking about, you know, I know different silicons in this group. Okay, this will be an issue for them. Okay.
Valid concern to raise, Rabbi. I'm not
Okay.
saying not.
Okay, so yeah.
Lisa, you had a comment as well. Sorry.
Yeah, I was going to say that, you know,
Mhm.
certainly the FPGA is a stepping stone towards that direction, right? And we do recognize that it is potentially multi-generations before we get it in silicon.
Maybe I can suggest something different a little bit, Reza. I can tell from our experience what is difficult and what is, you know, what is difficult and what can be achieved. Okay, if you're talking about the standard off-the-shelf SoCs that are repurposed to be DPUs, okay, modifying config space is extremely difficult because typically those are synthesized, you know, IPs that are inside the silicon, and that's it. You cannot change anything with them. But what you can do is that sometimes you can change class ID and subclass IDs, okay, and then accordingly, okay. For instance, if we go to PCI SIG and tell them, hey guys, we need a specific subclass ID for the networking piece, and it cannot be, you know, a regular Ethernet adapter. It can be a DPU. And if you say that, okay, then the firmware that is inside the BIOS, okay, will scan the bars in physical function 0 and look for something specific, but will tell it to do like the OS boot select, the OS status, you know, if there's a crash dump status. Okay, so do you see the difference? The difference is that you will go through a memory mapped IO to the DPU itself inside inside the DPU itself. Okay, instead of, you know, having an additional capability list. Okay.
And maybe I think what you're hinting at is while we're mapping out a longer term approach, maybe there's an intermediate approach as well that can be addressed and suggested.
Yeah. Just with a new class and then with memory.
New class, or maybe through the config space, you know. I mean, you know, at the end of the day, there are 2 or 3 different, you know, vendors for PCI IPs. Okay, it's not that you have hundreds of them. Okay, those can be mapped into 2 to 3 different vendors. Okay, and you know, this is the market. Okay, this is a silicon that is out there, right?
And yeah, and I think that approach works if, you know, if those functions are up and running, right?
Right.
Immediately after reset, that those functions are accessible.
Yes.
If we need to wait another, I don't know, 10 seconds until the OS boots, or maybe longer, 30 seconds, then, you know, this is not going to work. This assumes that immediately after reset, this function is available. So Rabbi, by any means, if you see that alternative approach or intermediate step in approach number 1 is something that you can propose, absolutely. Go for it. Great pull request. I will review and merge. No problem.
Okay, so Reza, so I think slightly modification to your in-band PCIe would be really having physical function 0 ready within 3 seconds. I think this is a must. Okay? Without it, you know, we will have, you know, terrible time penetrating different markets. Okay, it would be like for every customer you would need to explain how to halt his UEFI BIOS until something happens. Okay. So
And
I would
Reza,
put-
I understand correctly. We didn't write the assumptions in number one, but the assumption here is that server providers will have to change their BIOS in order to change and accommodate for this behavior.
it's a major thing. Okay.
That's the right assumption, Reza?
Yes, that's correct.
Okay, thanks.
I have a few servers over here. If you wait 15 seconds, that's it. They will reboot. Okay, if you don't like release config space, okay, they will simply reboot.
I know we as Dell and Reza as HP, we all experienced with all the different behaviors from DPUs.
So this must be, so the experience, in my opinion, again, and please, apologies for being, to be too blunt on this. But if we do not, as a whole, provide a good experience for anyone that is for server or desktop for evaluation, okay, it's a lost war. Okay, this is my 2 cents. Okay, we need, the experience must be that people plugs in this DPU and they can work with it without, with minimal features at least. Okay, and then you can, once they are happy with the beginning, okay, they can add more features, instantiate more virtual functions, physical functions, whatever you want to do. But at least the bare experience, the first experience must be pleasant. Otherwise, they're gonna buy a sample, plug that inside their server or desktop or whatever. Okay, boot it up, see it doesn't work. That DPU is gonna be on the side forever, unless they pick up, of course, the phone and talk to you. But this becomes a support issue rather than a fluid and a good experience. Okay, so back to this. Okay, I would suggest in physical function 0 really to be ready within 3 seconds. And then beyond that, play with either device ID, vendor ID, or subsystem vendor ID, or class, subclass ID. And then you can, if it's a limited number of physical function 0 statuses, okay, we can provide, we can use all sort of reserved fields in config space to indicate.
So Rabi, maybe instead of all different possibilities, maybe you can help us and create a concrete proposals. What reserved capabilities, how the new class code and subclass, what specific fields we can play with. If you can create a concrete example of how that would look like, then we can having something more concrete in front of us, and we can then discuss it and review it. Okay. I'm absolutely agreeing with you that having something intermediate can be helpful. So instead of just being very high level, if we can get a little bit more concrete proposal, I think that will be extremely helpful.
Okay.
Additional comment that I have is on the existing approaches for the short term. I think that it's not a secret that today, if you look into open information out there and publications and white papers, we see that some or many server vendors chose approach number 3 due to all the limitations that we talked about. So today, all the offerings, so many of the offerings that we see with DPUs integrated into the servers, and Reza, correct me if I'm wrong, I'm not sure about HP, took today the approach number 3.
Well, we have a hybrid approach.
Hybrid, okay.
Yeah.
Thanks.
Just one note
on that.
Yes, Vipin.
Yeah, Boris, on that note, I think there was someone who expressed the sentiment that if we are going to be a generation of these devices away, and if it's going to take like a couple of years to really get there, do we really want to explore 3 as a primary thing, especially if it is already in place or a flavor of it is already in place one way or the other? It's not perfect, but it works with what we have and tries to manage the situation.
But what it means, I'm just trying to wrap around what your comment says. So let's say we do that. It means that all the server providers and all the DPU vendors will have to implement option number 3. And then in a couple of years, they'll need to re-implement everything to option number 1, for example. I'm just trying to understand.
No. In that case, we just go and implement option number 3 and just try and improvise that. So there is no PCI, I would say spec changes needed, which was also a concern raised by someone. And it works for brownfield. It's a software implementation from what I understand. So we can all incorporate that in the devices that exist today. I'm speaking for myself, but maybe others can speak more.
So again, sorry for not being last meeting. Okay, so this is extremely important, but we are seeing deployments where it's in server without any BMC. Okay, those are very small servers. Okay, edge computers that are in offices that don't have any BMC, and the DPU is completely used for isolating that server from the infrastructure. It's not a big thing, you know, from a deployment point of view, but we are seeing this use case. So what it means is that people, you know, having a standard small servers, ruggedized servers, okay, and they want this to be isolated from the local area network. So they use a DPU to do the virtualization of the whole network infrastructure of that server, okay, and to remotely access that server through the DPU. And
Original servers on edge without any board management controller?
No BMCs at all.
So who controls power, fans, cooling, all of that stuff?
The associated, the CPU itself. So the CPU takes care about its power management, and the DPU takes about its power management. Again, this is a small setup, okay, and this is for completely isolating that server from the infrastructure. Okay, and the management of that DPU is completely done out of band from dedicated, you know, 1 gig Ethernet.
I don't think Rabi is changing anything, right? Because BMC can be a separate chip, but maybe BMC can be a process inside the main CPU. Who cares? Like micro BMC that I don't remember who suggested to OPI.
Silicon suggested.
Yeah, Silicon. So yeah, could be still a case, right? It's not precluded from one another, no? Or it have to be a separate chip.
And in this case, Rabbi, the XPU does not have any PCI violations, right? This
No.
comes up, all the functions are available.
Yes, definitely, and it's even much more simplified. There's even no virtualization in those use cases.
Yeah.
Everything is a simple physical function 0, physical function 1, physical function 2, whatever you have on the DPU, and it's completely, you know, providing network and storage for the host, you know, all virtualized, of course, network, and I mean virtualized from, I don't know, so what's the right word? It's not an SRIOV kind of deployment. Okay, it's a physical function, but the network is encrypted, okay, and encapsulated multiple times over the WAN networks, and the same thing for the storage. Okay, it emulates an NVMe for the local machine, but the actual volume is remotely like encapsulated.
Right. So there is a class here. It seems that, you know, there are multiple classes of XPUs. One that does not require boot coordination, which is, I think, what Rabia is talking about, and then the ones that some of the other versions that do require boot coordination.
I don't think so, Riza. Rabia, how the NVMe emulation works? Like, is it available immediately, or still there is need to be created?
So it goes like this. Okay, the first boot. Okay, this is typically a bad boot. Okay, let's call it like this way. The first boot is where the DPU connects to the orchestration, remote orchestration, gets a URL about where it will be mounting its, you know, final volume. Okay, and then the next reboot, okay, it will show as an NVMe drive, okay, with 150 seconds timeout. And in the meanwhile, the DPU would go, you know, would boot very, very fast, okay? And then it would go and mount that remote volume from the previous configuration, and then we'll release, you know, it will release the DPU boot sequence. You know, Alvaro is in this call, okay? He can provide you the details if we have. I mean, we have done something exactly similar to this.
How,
Okay,
how,
so Mhm.
who coordinates the reboot? Who?
Yeah,
is-
the reboot and the release that you're talking about. That
Okay,
DPU
so-
will release. How?
so there is a boot, okay, there is a power up. There is a PCI reset. In this case, okay, in this kind of deployment, okay, the PCI reset is deasserted, okay, and the reference clock on the PCI bus is already available. Okay, our DPU starts booting. It will boot very fast. Okay, the physical function will be there like immediately. Okay, and the whole logic behind it will be available like in 10 seconds to 15 seconds, which in that meanwhile we will boot like a Linux. Okay.
So
Now-
how you hold host in reset until that time?
Okay, so the host is not held in reset. The host already has seen NVMe volume. Okay, and has already seen that we have an NVMe volume, but it's pulling until that NVMe drive is ready.
Ah, so it's using, okay, I see. It's using the special NVMe driver ready bit in order to understand that the NVMe is ready.
Yes. In the meanwhile,
this is-
Mhm.
I think this is approach number 2. With NVMe device driver will pull SSDS ready bit to ensure infrastructure backend. So I think what you described in is proposal number 2.
Yeah, but proposal number 2 does not say that the PCI must be ready, right?
Well, yeah, it does. That's under the assumption there.
Yeah, assumption.
So it's a
Must
mix.
follow PCI Express and be ready on the bus's enumeration time.
Okay.
And then after the device is ready, then if that's NVMe, on NVMe we can do the poll for the ready bit. If it's not NVMe and VirtIO net VirtIO block, there is kind of special device signaling.
It's an option room. Once you have an option room, you can do whatever you want.
Exactly.
But
Okay.
we're talking without option room. We're talking
Yeah.
about the native NVMe driver in UEFI.
Yeah, I understand.
Yeah, I'm sorry, I need to drop to host another
Yeah,
call.
so I'm also, so let's wrap it up. Thank you for participation today. Rabia, let's continue that. If we can submit several proposals, we can discuss that for sure. Thank you, everybody, and see you next week.
Thank you. Goodbye.
Thank you.